Question 2 says, the water temperature in a lake in degrees Celsius is measured over a 15-day period. The temperature is modeled by a differentiable function, W of t, where t is measured in days. Part A says, use the data to estimate W prime of 12. Show your computation and include units. Now, I actually don't like these estimate problems very much because there's a lot of different ways you could estimate it. W prime of 12, well, here's 12 down here. So one of the things that you could do, and this is what I'm going to do, is we're going to take 12 and one other point next to it. I'll just pick 9. And then just find the slope. You could also do the same thing with 12 and another point like 15. You could even do both of these maybe and find the average of the two. Or perhaps you could even take the 2 points that are just around it, like 9 and 15, and then find that slope. So there's a lot of different things you could do here. Like I said, I'm just going to do this here. So we're really just going to think about this kind of like a set of points, 9, 24, 12, 22. And we're just going to use our trusty old slope formula here. So we got 22 minus 24 over 12 minus 9. So we got negative 2 and 3. So I'm just going to say negative 2/3 is the answer. We do have to show our units as well. Now let's see here. We started with W of t, which was the temperature. We're estimating the derivative. So this should be temperature per time. So this should be Celsius, degrees Celsius, per day, like this. Part B says estimate the average temperature over the interval 0 to 15 using the trapezoidal rule with time steps of 3 days. So when you're doing the trapezoid method here, it's going to be 1/2 times delta x, and then f of whatever our first piece is, plus 2 times whatever our second piece is, and you're going to keep doing that until you get to the very last piece. So just kind of informally, this is what I'm going to be using here. Delta x, though they kind of told us what delta x is, it's the time step of 3 days. It's the difference from here to here to here to here to here to here. And because it's the same each time, it's 3, it's okay to have out here. If these were at different time steps, like maybe the first one's 3, the second one is 4, then we're back to 3, and then 2 again, you'd have to include that inside the parentheses here. You couldn't have it outside like this. So here's what we're going to have. We're going to have 1/2 times delta x, which is 3. And then we're going to do f of 0 plus f of 3. Or maybe I should be using w at this stage. We'll do w of 0 plus 2 times w of 3 plus 2 times w of 6 plus 2 times w of 9 plus 2 times w of 12 plus w of 15. So the first and the last piece, w of 0 and w of 15, those are not multiplied by 2. It's only the middle pieces that are multiplied by 2 here. So let's hear. We have 1/2 times 3, which is going to be 3/2. W of 0 is 20. Then we have 2 times 31 plus 2 times 28 plus 2 times 24 plus 2 times 22 plus 21. And this is what you're going to plug into a calculator. And if you do this, you get 376.5, like that. And that's our answer for part B. Part C says a student models the lake temperature using the function given here. Find P prime of 12 and interpret its meaning in the context of the lake temperature. Well, here's one thing that I'm going to do before I start to find the derivative, because I think this will help a little bit. We have this exponent here, this negative t over 3. And instead of writing it as negative t over 3, I'm going to rewrite it as negative 1/3 times t. Because when you're finding derivatives, usually you're kind of primed to find the derivative of like this, with a number in front of the variable. It'll be a little bit easier as we go through. Okay, so when we find the derivative of a constant is 0, so we don't have to worry about that. Over here, we're going to have to worry about the product rule. So we need the derivative of 10t times the second piece plus the derivative of the second piece. So this will be e to the negative 1/3 t times the derivative of negative 1/3 t, which is just negative 1/3, times the first piece, 10t, like this. All right, so let's take a look at this here. We have 10e to the negative 1/3 t, and then we have this minus 1/3 times 10, so I guess minus 10/3 t e to the negative 1/3 t. And then what we can do here, well, I was going to say we should factor it, but I don't think there's really a need to, because what we're going to do now is we're going to plug 12 into this for t. So we're going to get 10e. Let's see, if I plug 12 in here, that'll turn into negative 4 minus 10/3 times 12 e to the negative 4. And you're going to plug that into your calculator. And what you're going to get is negative 0.549. 549. Now, let's see here. This is kind of like what we did in part A. We started with a function, p of t, which models the temperature. We found the derivative. So if we started with temperature and we found the derivative, this should be temperature per time, or in other words, degrees Celsius per day, like this. Part D says, using the function, p of t, compute the average value of the temperature over the interval. Now, this is the average value, so you want to make sure that you're using the correct formula here. The average value formula looks like this. You don't want to use the average rate of change formula. I've seen students do this. They will see the word average and immediately fill in the rest in their heads and use this. Not true. Average value is what we're doing here. So we're going to do 1 over 15 minus 0, because that's the time interval, from 0 to 15. And then, of course, we're going to need the previous function, which was 20 plus 10t e to the negative 1/3 t, like this. This is what you're going to plug into your calculator, and when you do that, you're going to get 25.757. And let's see here, this is the average value. So this is the average temperature over that time period, 25.757 degrees Celsius.
If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.